Hey all dear sons, this is Pradesh Chaudhary, Quantum Guru. Isn't it quite unusual for the ball to land on the same side of normal after collision? But this is a real clip from a real match from Paris Olympic 2024. So here what happens, this is a table tennis ball, it strikes this surface this way, and instead of going this way, it goes backward on the same side. So under what circumstances this happens? This is quite rare, it not happens quite often. So we'll study quite in detail under what circumstances this happen, and that is the topic of this video. Normally, suppose I have a table tennis ball and I have a racket, and if I hit ball this way normally, so what happens when I hit normally? The force applied is normal and no friction is there, so it doesn't get any angular velocity. But usually the ball is here and I hit the table tennis racket this way, so a friction is there between ball and the table tennis racket at the moment of hitting, and that will, if I hit this way, so torque due to friction provides this kind of angular velocity, and if I hit this way, so torque gives the angular velocity in this direction. So it is quite usual for the ball to have angular velocity when hit by a table tennis racket, but I am talking right now, I want to take a case in which the ball has no angular velocity. So this is a fixed surface is rough, it has a coefficient of friction mu, this is a normal, and that would be the LOI for the collision, and E is the coefficient of restitution. So here is the ball and that is going to collide the surface. This is the line of motion just before collision. I is the angle made by the velocity vector with the normal, and I'll call that angle of incidence. We can get the analogy with the reflection of light. So the component of the velocity before collision, normal to LOI is ux, or parallel to the surface is ux, and parallel to LOI or normal to the contact surface is uy. So alright, so now this is the moment of collision. So at the moment of collision, it had a vertical downward velocity, so it started pressing the surface, so immediately a normal will come. So normal will come, and it had a horizontal velocity ux. So this has a velocity ux, and it has no angular velocity, so it is in a pure translatory motion. So all points of the body has the same velocity, so point of contact has also same velocity ux. So you can see this point of contact has a velocity, the surface is fixed, so there is a relative motion between them, and the normal is there, surface is there, surface is rough, so friction will come. What type of friction will come? Obviously kinetic friction will come, because there is a relative motion. So a kinetic friction will come opposite to the relative motion. So what is the job of this kinetic friction? This job of this kinetic friction is to destroy the relative motion. So now this n is a very huge, suddenly it has come, so it is impulsive normal, so this friction will also be impulsive. So the ball has come here and it will press, and surface will press, and it will deform and will leave. So though it happens quite immediately, it seems quite immediately, but there is a finite time of the order of 10 to the power minus 3 seconds, and though time is very small, but this normal is huge. So even that small time interval is enough for this enormous normal to change the momentum along the y direction. So when it will leave, it will have a vertical upward direction velocity, and meanwhile this kinetic friction will also not be silent, it will also do work. It will reduce this forward velocity. So when it leaves the surface, the ball has an upward velocity vy, and because of the action of friction, this ux has decreased and it has now become vy, and a final velocity vector makes angle r from the normal, from the LOI. So now we can write some equation. So first of all, I can write impulse due to normal taking upward direction as positive. So impulse due to normal, impulse, that is the net impulse, Net impulse is the change in momentum. So final momentum is mvy and initial momentum is minus muy because upward direction is positive. So that will, and this from the collision result I will directly write the E is the coefficient of restitution. So E is the velocity of separation along LOI divided by velocity of approach along LOI. So after collision the velocity of separation is Vy minus 0, and before collision velocity approach is Uy minus 0. So E is Vy by Uy. So Vy is E times of Uy. So here in place of Vy I have written E times of Uy and simplified that thing. So I will get n dt integration is m into 1 plus Euy. And there would be another impulse because of this mu n, and for that thing I'll take the right side direction as positive. If I take right direction positive, so I will read this force as a minus mu n. So impulse of this minus mu n would be integral minus mu n dt, and that would be m into vx minus m into ux. So and that I have simplified. So minus mu integral n dt is equal to mvx minus ux. And from geometry you can see that this 10i is equal to ux by uy, and here 10r is equal to vx by vy, and the thing that I had already used this vy was E times of Uy. So these are the things that I've already used. Now let's go to next page, and I want to divide these two to get rid of this unknown in value n. So dividing these two I will come in terms of those things which really matters. Oh, these were the equations. So divide these two equations. So first of all on the RHS part, so that would be Vx minus Ux upon 1 plus Euy, and on the other side that would be minus mu. Just rearrange that thing. So we'll get Vx is equal to Ux minus mu into 1 plus E into Uy, and take Ux common. So that would be ux into 1 minus mu 1 plus E Uy by ux, and this ux by uy was 10i. So I have Vx is equal to ux into 1 minus mu into 1 plus E upon 10i, right? Okay. And Vy was E Uy. So again divide these two equations. So Vx by Vy is equal to 1 minus mu into 1 plus E upon 10i into ux by uy, and ux by uy is 10i, and Vx by Vy you can see from here 10i is the ux by uy. So ux by uy I'll write 10i, and 10r would be Vx by Vy. So this is 10r, 1 minus mu into 1 plus E upon 10i into 10i by E. Just multiply it and simplify further. So we will get 10r is equal to 10i minus mu into 1 plus E by E. If you remember your class studies, and you would have taught that if the surface is smooth, so 10r is equal to 10i by E, and that you can get here. Surface smooth, just put mu is equal to 0. So you will get this result that you have been taught in your class, that 10r is equal to 10i by E. But now the surface is rough, so we have a more general result. Alright? Okay. Now we'll take few cases, all possible cases. So that was the result that I have obtained. So the case 1, a numerator is interesting. So there can be three things. This numerator can be positive, numerator can be 0, or numerator can be negative. So I was interested in the case that the ball goes back. So for me, this, for I, this is the positive direction, for R this is the positive direction. If R comes negative, so that would mean that it goes on the backward side. Whether it is possible or not, that I have to explore. So first of all, this case 1, tan I is greater than mu into 1 plus E. So tan R would also be greater than 0. So R is positive, R is acute. So in this case, the ball will go to the other side of normal as this picture is looking. So that would be like that. After collision, particle will go to the other side of normal like this. Okay. And that is case 1. And case 2. Tan I is equal to mu 1 plus E. Now that is a critical case. So in that case, tan R is 0. Tan R is 0 mean R is 0. R is 0 mean the angle made with the normal is 0. So after collision, ball will rebound normally. Like this, ball comes like this and it goes vertically upwards. So that is very interesting case. And the most interesting case is this. If tan I is less than mu 1 plus E, so this would be negative, tan R would be negative, tan R would be negative mean R is negative, R negative mean the ball after collision should go to that side, and that was the clip was showing. So particle should rebound on the same side of normal after collision like this. But does it really happen? Let's see. So still investigation, getting the case 3. So here, see, at the moment of collision, this point has a velocity same as the velocity of the center, and the kinetic friction will act. And remember, what is the role of kinetic friction? The kinetic friction role is to destroy the relative motion. So, and it will act only till time there is a normal. So it is trying to destroy the relative motion, and it has a time ticking because it can act only till there is a normal reaction. So by the time it leaves, this force can do few things, like it can reduce this velocity, like after the moment it leaves. It can reduce the velocity up to this. It can reduce velocity up to this. It can reduce velocity up to this. By the time it leaves, when the normal becomes 0, it can make velocity 0, and that was just the last case. Can it make velocity along this direction or along this direction? That would be opposite. The moment it has brought velocity up to here, mean it is succeeded in destroying the relative motion. Its job is over. So even the body has not left the contact. The kinetic friction will disappear at this moment. The moment the velocity of the lowest point becomes 0, mean the relative motion between the ground, the surface, and the lowest point has destroyed. Immediately the kinetic friction will go away. So in no case it can bring this Vx in the opposite direction. It can decrease the value of Vx from Ux, or it can bring Vx to 0, but it cannot make it on the backward direction because its job would be over at the moment the Vx becomes 0. So in that case, the R would be 0. If that comes negative, so the R will become 0, like that. Okay, so R is 0, and now we can summarize the result. So what we got here, so if the ball is not rotating, ball has not angular velocity, so after collision it can never go on the same side. So I can summarize the result. I have chosen one I. This I naught, this angle I naught is the angle at which tan I was equal to mu into 1 plus E. So then I is equal to I naught, and that I naught is equal to tan inverse mu into 1 plus I. So if I is greater than or equal to 10i, I is greater than or equal to I naught, so in that case 10r is equal to this, and when I is less than or equal to I naught, then it was 0. So again that thing I will show here, that is I naught. If the ball strikes at an angle of incidence greater than I naught, then it will rebound to the other side. If the ball strikes at I naught, it will rebound normally, and also if the ball strikes at an angle less than I naught, still it will rebound normally. In no case it will rebound on the same side. So what was that clip then? That happens when there is some angular velocity of the ball. So that is the case 2. The ball has angular velocity, you can see that is a backspin. The ball was moving like that, the ball was, now I have changed the direction, the ball is moving like that, it is going to hit at an angle of incidence I. Velocity is component ux, uy as shown earlier, that is ly, mu and er as shown. Now I will not go for the calculation part, I will just show whether it is possible for the ball to land on the same side or not. So the ball, now this is the moment the ball strikes. The moment ball strikes the surface, it has a velocity of center mass ux and has some angular velocity as shown. That is a backspin. So point of contact will have a velocity in the forward direction, that would be ux plus r omega. And obviously the ground has no velocity, so there is a relative motion. A kinetic friction will come. So kinetic friction will come to oppose the relative motion. Now for this body I am not showing mg and normal, they will cancel, neither they will give any acceleration nor torque. This mu n will produce an acceleration of the center mass, and this mu n will also give some torque about the center mass in this sense. So it will have an angular velocity. See, this acceleration is opposite to the velocity of center mass, and this angular acceleration is also opposite to the angular velocity. So this a will decrease ux and this alpha will decrease omega. So now both are opposite to their, a is opposite to the velocity and alpha is opposite to omega. So both will decrease their counterpart velocity or angular velocities. So now three things can happen. V and omega become simultaneously 0. So then in that case it will go vertically upwards. And I am interested in what case it goes in the on the same direction. So there can be one case in which the V becomes 0 first. If it is given a very heavy backspin, so it will take a long time for omega to become 0. So V has become 0. V has become 0. Ux, this velocity of center mass, has become 0, but omega hasn't become 0. Obviously it would have decreased from that value. So let's see a moment where because of this action it has made ux to 0 and alpha has decreased omega, but still it is not able to destroy it completely. So that is the situation. So now what is the velocity of this point? This point still has a forward velocity. So forward velocity r omega dash, that would be, in the previous case, if this velocity was 0, then the normal kinetic friction would have stopped working. So in that case the body goes up like that, but Vx has become 0 but omega has not become 0, so this point still has a forward velocity, so kinetic friction job is not over yet. So kinetic friction will still work opposite to this velocity. So because of this, again there would be a and alpha. And now I am interested in a. So at this moment the velocity has become 0 and acceleration is backward direction. So and the body has not lifted yet. So any little time whatever it will get, it will turn back the velocity in the opposite direction like that. And this alpha will further decrease this omega. So now I have written that omega dash. and that is the moment it leaves. So at the moment of leaving, it has a left direction velocity of the center mass. So that is the case that the body just bounces back on the same side. So this is a Vx, that is Vy, and for the Vx Vy calculation are the same, because I am interested in the motion of the center mass. I am not interested what is the angular velocity. Same calculation, but it goes on this side because of that omega Vx has become 0, so friction will still act, and that is the case on that clip.